Oops, hello class. I wanted to go over your bone quiz. It was less than stellar. Probably one of the worst bone quizzes I've ever given as an instructor, so I'm not quite sure what went wrong. So I wanted to go over the quiz with you, because if you don't understand the basic stuff, you are not going to do well. So let's just go through the quiz again and just kind of see. I'm trying to figure out what went wrong. This was the first question. First, you look at this. You've seen this picture before. This was on your worksheet. So I don't understand why some of you didn't get this. This is what we see here. What are these round things? These are osteons. Osteons are found only in compact bone. This is compact bone. Here we go into our spongy bone here. But osteons are in compact bone. So you look at this. I'm asking you for the two canals that are supplying nutrients to our bone. Here, coming from the outside, coming out this way, here's the periosteum out here. This is Volkmann's, aka perforating canal. Perforate, penetrate, it's perforating coming in. It is meeting at right angles to this canal. This is the central canal, aka Haversian canal, but central canal, you see central canal here, 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 here. So you got to know that. In this osteon too, since we're here, what kind of lamellae are here that make these rings? Concentric lamellae, the one that goes all the way around the bone. This is circumferential. In between the bone, in between the osteons is interstitial lamellae. So make sure you know those two. Now here was one of our slides that we looked at. Everyone saw this. You said you all knew where all these things were when we were looking at them. So on a close-up here, these black things here, these are lacunae. This is dead bone. Dead bone, I mean, it's dead. This is dried bone. There are no live cells in here. Yes, the osteocytes once lived in here, but this is dry bone. No living cells live here. These little black squiggly lines, those are the canaliculi. Here's your central canal, and each one of these is a concentric lamellae. So not sure what you guys didn't get with this one either. So now we talked about the bone, the bony matrix. What composes the bone matrix? We have collagen fibers, and we have a ground substance that has been mineralized. It's hyaline cartilage matrix that's been mineralized with calcium salts to make it hard. So calcium salts make the matrix, well, the ground substance, hard but brittle. And I showed you the pencil. If it just snaps, it's hard, yes, but it's brittle. The collagen fibers in the matrix give bone tensile strength, the ability to bend without breaking. So this little girl, I told you she has multiple fractures. Her bones are easily fractured. What could be wrong with her bony matrix? This is brittle bone disease. Brittle bones. What's lacking in her matrix? Collagen fibers. Her bones are brittle. Genetic condition where they can't manufacture the collagen protein fibers. The matrix is hard but brittle. Just snaps. The bones snap. Now this little guy, he stands up his bones bow out. What's wrong with his matrix? The bones aren't strong. They can't support his weight. So he lacks calcium. There's a lack of mineralization in his matrix. So soft bones. 1, 2, 3, 4. Here's question 4. This even looks like a bone, doesn't it? This even looks like a bone. So if I saw this, or if you see this, you should go, wow, it looks like the epiphysis up here. And down here is going to be the diaphysis. Oh, here's the epiphyseal plate. And you know that, even if you weren't sure, here they're showing you this. What is this? This is the 5 zones of endochondral ossification that we went over. So even if you weren't quite sure, you can go, this must be from the epiphyseal plate of a bone. And that's what it is. So that was question 4. Oops. Then this question, this was a slide in our classroom. This slide said endochondral ossification. Some of the slides actually said epiphyseal plate. This top zone up here, I'll just start over here. This is the resting zone, plain old hyaline cartilage. When they start proliferating, dividing, they look like coins that are stacked. So this is the proliferation zone. So this first part was the resting zone, proliferation zone. Then they're going to start getting big. These chondrocytes are going to get real big. This is called the hypertrophic zone. And they start mineralizing their matrix, and they start dying. So down here, where we see no nuclei, is just white empty shells here. This is the calcification zone. The chondrocytes up here have died. And then here is the ossification zone, making new bone. Blood's coming in, lots of making new bone. Resting zone, proliferation zone, hypertrophic zone, and then the calcification zone and ossification zone. I thought I put in another picture in here. I guess I didn't. Oh, actually, I put it down here. I wanted to show you this. This is a close-up, extreme close-up. Resting zone way up here, just plain old hyaline cartilage, proliferation zone, hypertrophic zone where their cells are getting big, calcification zone, the cells are dying, just a white empty shell. The chondrocytes have died. Remember, these are chondrocytes. And then here's the ossification zone. So make sure you know that. Make sure you understand that. So let's go back up to this question. So this is the back of the skull. What is this major suture right down the middle of the skull? This is the sagittal suture right down the middle. On either side of the sagittal suture is a parietal bone. Left and right parietal bones. This bone back here is the occipital bone. Here's the lambdoid suture right here. Here's the external occipital protuberance right here. So this one is so easy just because it's color coded, and you will not have anything color coded on an exam. This pink bone is the temporal bone. That's where you start with. What bone am I in? The temporal bone. This is the zygomatic process of the temporal bone. You have to say of the temporal bone, zygomatic process of the temporal bone, mastoid process of the temporal bone. This is this hole here, the external acoustic meatus of the temporal bone, styloid process of the temporal bone. Here's your parietal bone, occipital bone, frontal bone. Here's the greater wing of the sphenoid, the zygomatic bone, the maxilla. You can see a lacrimal bone in here. The ethmoid bone is going to be the green one. And here's your mandible. Here's the angle of the mandible right there. The angle of the mandible. The ramus is this angular extension. And here's the condylar process. It carries the head of the mandible. The head of the mandible articulates with the temporal bone at the mandibular fossa of the temporal bone to form the temporal mandibular joint. So when you're looking at this, always try to see what you still know. Remember, this is the temporal process of the zygomatic bone. I added another skull here, just because I thought this was good. What bone is here and what bone is here? Together they're making up the nasal septum. This one down here is the nasal septum. This one up here that's coming down, it's usually broken in all our skulls, our real skulls. This is the perpendicular plate of the ethmoid bone. I like this one because you can see the cribriform plate up here. Remember, the cribriform plate's part of the ethmoid bone too. That's where, when you're smelling stuff, it trickles through the cribriform plate. This guy here is who? This is the inferior nasal concha. There's one here and one here. I don't know if you can see it here, but this is the middle nasal concha, and these belong to the ethmoid bone. So here is the right and left maxilla. Here's where their line of fusion right here. So remember, if you have a cleft lip, something went wrong with the fusion of the right and left maxilla. I think that was it, and then I wanted to go to just some stuff on your worksheet. See, don't save that. Oh, actually, the first thing on your quiz. The first thing on your quiz was to draw a typical long bone. Draw a typical long bone, and I had a bunch of things I wanted you to add on it. Here is just an outline of a typical long bone. This dark purple represents compact bone. All bones have compact bone on the outside. What you see when you're seeing a bone is compact bone. It's pretty thin. So start with that. You draw compact bone. That is all compact bone. This is your proximal epiphysis. The diaphysis is this long part, also called the shaft, and down here is the distal epiphysis. Epiphysis is just the widening area up here. The wide part up here is going to be carrying the articular surface on either side. So now let's go, so you start off with that compact bone. On either end of a long bone, we are going to have an articular surface, meaning it's going to articulate with another bone. So on either end of a long bone, we are going to have articular cartilage. This is hyaline cartilage. Remember, hyaline cartilage is found at the ends of all long bones. This bone is going to articulate with a bone above it, and it's going to articulate with a bone below it. So on top of the compact bone sits the articular cartilage on either end. Then you're going to add periosteum. Peri means around, osteo means bone, so this is the covering around the bone. It starts where the articular cartilage stops. It's attached to the compact bone, just like the articular cartilage is attached to the compact bone. So the periosteum starts where the hyaline cartilage ends. It goes all the way to the other side where we have articular cartilage. Okay, so and then now we said this bone was cut. This is a frontal or coronal cut, so we are looking inside the bone. So I showed you a real bone in class. You looked at the ends and you saw all that honeycomb fine bone. That was the spongy bone. So the X's here, the silver X's represent spongy bone. And inside the proximal epiphysis of the humerus or the femur, that's where we're going to find the red marrow. Red marrow is only in the proximal epiphysis, not in the distal. And we have in between the proximal epiphysis and the diaphysis up here, we have either epiphyseal plate or epiphyseal line. Same thing down here between the distal epiphysis and the diaphysis, epiphyseal plate or epiphyseal line. You need to know the difference between a plate and a line. Plate still has cartilage. That is your growth plate. A line, the cartilage has been replaced with bone. It's been ossified. In the center of a long bone, you have a cavity, a space. That is the medullary cavity. In adults, it's filled with yellow marrow. So yellow marrow. I think that was all you had to know to draw, but I'm surprised. I don't even think one person drew it right, so it was just sad. Now, when you go to your worksheet, and I just kind of assumed you did all your worksheets, there are questions that I ask here. What are perforating, aka Sharpie fibers, and why are they important? What's the difference between epiphyseal plate and line? Where is yellow marrow found? Where's red marrow found? Make sure you answer all these questions because you will see them again. Periosteum. Here we've taken the periosteum. They're showing you the periosteum. They're pulling it off the bone. The fibrous layer. Why is it called the fibrous layer? That is the outer fibrous layer. That is dense, irregular connective tissue. The cellular layer is the inner layer. It's cellular because it houses the two bone cells. The osteoclasts and osteoblasts live in this cellular layer of the periosteum. They also live in the cellular layer of the endosteum, but in the periosteum, it's the inner cellular layer where osteoblasts and osteoclasts live. So these are Sharpie or perforating fibers. These white things here, what are they? They're collagen fibers. They are connecting the periosteum to the compact bone. Really important to connect that periosteum to the compact bone. And then I ask you this question. This was one of the questions on your quiz. Know the function of an osteoblast, osteocyte, osteoclast, and where each is found. That was another one of your questions. This was just going through it again. Here's your Volkmann's canal, central canal, osteons, circumferential lamellae, concentric lamellae, interstitial lamellae. Here again you see the periosteum pulled off. Remember we said the periosteum is a source of blood and nerves to the bone. So here you can see it. What process makes the bone matrix different from cartilage matrix? Another question. Here I'm asking, are osteons located in spongy bone? Here's spongy bone. No, osteons are only located in compact bone. Are osteocytes located in spongy bone? One of the questions is, where are osteocytes located? They're located in lacunae, in compact bone, and You see lacunae down here in the spongy bone? Osteocytes have to maintain the bone. They're in the spongy bone down here too. And this was just your worksheet. Same thing, looking at a dry ground bone preparation. This type of preparation destroys living cells, so you have to know there are no osteocytes in here, just lacunae. And then there's a bunch of questions here. I think all these questions were on your quiz. So make sure when I give you a worksheet, if there's questions, answer the questions. If you don't know the answers, talk to me. You can find all these answers in your lab lecture notes, in your class lecture notes, the ones in class, online, the PowerPoint that I presented. You can find it, your textbook, you can find all these answers. Anyway, I just wanted to go through that quiz with you because it's real important that you understand this. Okay, bye. See you in class.